Okay, what we're making here is a illustration that will serve as a proof to the Pythagorean theorem. The Pythagorean theorem we'll get to in a minute. Let's just plot 2 points first. The first point I want at 2, 1. So taking this starter file, go 2 on the x and 1 on the y, and then label that accordingly. And we'll use this label here if it feels like moving. I'm not using a mouse and then having an issue with that. Goodness gracious me. Just trying to move it here. And okay, that's 2 on the x and 1 on the y. We need another dot at or point at 6.4. So I'll copy and paste this guy. And that's 6 to the x and 4 on the y. And I can copy this and just move that over here and label it accordingly. So what we're trying to do is find the distance between these 2 points. And the way you do that is you identify the rise and run. The run is the differences between the x coordinates. So in this case it would be 6 minus 2. And that plays out here. 1, 2, 3, 4. I'm 4 on what's known as the run. Okay? And then if you look at the rise, that's 4 minus 1. It's the difference between the x coordinates, or excuse me, y coordinates. Make sure you always go in the same direction both times. Here, 4 minus 1, and that would be the difference of 3. 1, 2, and 3. So the run is 4, the rise is 3. And if you remember the Pythagorean theorem, it's c squared equals a squared plus b squared. So think of this as a and think of this as b. We have to square those. And literally you draw a square in the proof. So you take the rectangle tool. Starting here, remember the run is 4, so go over 4 and then down 4. And that will give you a 4 by 4, okay? And think of that as a squared, a being 4. And so I need this to be semi-transparent, and you're seeing me just kind of line it up perfectly here. And so that would be the fill bucket, and you go to the plus sign under custom, and you give it a color and make it semi-transparent. And now you can literally see it's a 4 by 4 square. Copy that, and we're going to use this one to make the other one, which is only a 3 by 3. So you can hold down the shift key, bring it in a square, and we have something like this. Should want to grab that. There we go. And make that a little bit smaller here. And give it a different color. So come here, click on the plus sign, change the color, and you now have that one. Okay, this is B. I'll move both dots to the front here. So I'm holding down the shift key to select both, and then say arrange order, bring to front. And so this is A, this is B. We're trying to find the distance between here, and you can think of that as C. Now the Pythagorean theorem always works when this is a right angle right here. And we'll talk more about that when we label it. But again, we're trying to find out the distance between here and here. Well, it turns out it's the distance between here and here is the sum of these 2 squares. And then you find the square root of that. Well, the sum of these 2 squares, this is a 4 by 4, so that's 16. And this is a 3 by 3, which is 9. Well, 9 plus 16 is 25. Now, what you got to do is the square root of 25 is the answer. Well, the square root of 25 is 5, because 5 times 5 equals 25. So I know the answer is a 5 by 5 square. And so I come over here to the shapes, or I don't have to do that. I'll just take one I've already made, copy paste that. Boy, the natives are really restless in the classroom next door. Hold down the shift key and make it a perfect square still. And this is your 5 by 5. Make it a different color. Now we can bring this guy over here, and we need to tilt it, of course, and there's the free rotate button for that. And we're trying to put this guy right on top of this area. And it doesn't have to be perfect. But there's your 25, okay? Again, 9 plus 16 is 25, and that's the 25 here. And then if you find the square root of that, that's the distance. That's 5 right there. So what I'd like to do now is to label the inside, and then we'll put the Pythagorean theorem over here. All right? So one of the things that helps you think about the Pythagorean theorem is that when you make this drawing, you're actually making a triangle here. So let's go ahead and label this, okay? So what I'm going to do is simply use, you could certainly use a triangle tool, and that would work. You could also use a polyline, and I think I'll just do that. So come in here. And we want to give it a semi-transparent background. There's complete mayhem next door in my office here. Forgot to set transparency down. I gotta pause for a moment. So with the triangle there, you could take a text tool and label the sides A, B, and C. And you might want to zoom in a bit for this. One of the features of the text tool now is they have this auto shape, which I absolutely hate, and I always turn it off. Auto fit. So anyway, I'm going to label this side A. I'm going to use italics for this. And all I'm going to do is just place it right here. This is side A. I'm going to copy and paste this text box and label the other sides B and C. And of course, C is what we're trying to find in the Pythagorean theorem. Again, this only works with a right triangle. A triangle that has a right angle, a 90-degree angle. And what you'll see a lot of people do is specify that with a small square right at that spot. Usually it's a hollow red one, something like that. And so make the fill transparent, make the border maybe 3 pixels, and make that color red. And traditionally that's what you see. And that's just a symbol that specifies, yes, this is a right angle. And so you can zoom out now. And let's do the math that's inside here. This is 4 squared equals 16. This is 3 squared equals 9. And this is 5 squared equals 25. Okay. So we take some text here, and we're probably going to use white text that'll show up. So I grab another text box and turn off autofit. And let's see what we can do here. So this is 3 squared equals 9. And I'm going to make the font white. And I'm just going to type 3, 2 for now equals 9. Make this a little bit wider. And bring it over here. And of course the 2 needs to be superscript. So I highlight it, go to Format, Text, and superscript is right there. And so I have something like this. It might be easier to read if this was bold. So I did a Command A and made it bold. I'm going to copy paste this now. Down here, this will be 4 squared equals 16. And then finally, up here is 5 squared equals 25. I'm going to pause here for a moment. So I did make the font bigger in each one of these text boxes just by selecting all of it and increasing the font size. And now all that's left is to kind of label this and provide the Pythagorean theorem. And you'll do this with text boxes. So what I do is I just go ahead and type the superscript exponent 2 normally, and then I come back and later format it to be superscript. And so if you go to format text and go down to superscript, you'll get that format. And if you copy that format, you can apply it to the others. It's just, I find it easier to do it after the fact. And so now we're doing plugging in the numbers. And so A is 4 squared. And so I can just bring this in and do something like this. So it's 4 squared plus 3 squared. And then down here, we'll say c squared. These numbers here, 4 squared is 16 plus 25, or excuse me, plus 9, which leaves us with c squared equals 25. If you find the square root of both of these terms, then you've identified what c is. So that's the part we'll do next. So finally, the square root of c squared is just c times c. So c is the square root of c squared. And then what times itself equals 25? Well, the answer is 5. And that's the distance right here that we found. And so this is we could be considered a completed assignment. And this is the Pythagorean theorem in action. This is what's known as a classic 3, 4, 5 triangle. It usually doesn't come out that way. But the number, if you put these points anywhere on this two-dimensional plane and apply these concepts, the math will always come out. And this is very handy for video games where you're trying to determine whether or not you've contacted the object and maybe scored a hit. And so the Pythagorean theorem is definitely applied in gaming. and you just wrote a proof for it. Thank you.